Hey everybody. Today, you can see the title up on the top of the screen. What we're going to do is we're going to start working with multiple triangles. So what we mean is, and you can maybe see the diagram on the screen, we're going to start working through some problems that contain multiple triangles. I think today is going to be a really good sum up. Again, it'll be an opportunity to clean up some areas where maybe there was a few gaps, but otherwise, today should be a pretty smooth day. So I want to leave you with each problem for today. Working through each one at a time. You should be good to be able to problem solve your way through one. Okay? I want you to pause the video, give it a shot. Don't worry so much about your solution. We'll clean all that stuff when we come back. Okay? Pause it now. Okay, we're back. You can see that in the problem, you have to find the length of BC. So if I was to just go through and put an X for the purposes of talking about it faster, there's my length. From B to C, I need to find X. How can I do that? Well, the first thing I'm going to look at is, can I find it, let's say, directly? When I take a peek at the triangle that side X is a part of, I take a look at it and I notice, well, side X is a part of two different triangles. Triangle BDC, which is a right triangle, but also triangle ABC, which is not. And so my first act then is I really want to see, can I find it just on triangle BDC? I take a peek and I notice I don't have enough information to find that directly. Like, I know that it's a right angle and I've been given an angle. So, like, I do know that this angle up here would have to be 40, but I'm missing a side length. And so I can't use Pythagorean theorem. I can't use SOHCAHTOA to get there. I'm stuck on that triangle. Okay. I then take a peek and get rid of that blue. Remember, we talked about the big triangle. Well, the fact that triangle ABC is not a right triangle means I can't do anything there either. But if I take a look at the other triangle that is in that diagram, triangle ABD, then I notice something very useful about it. First off, notice that it is a right triangle. Although it isn't marked in that triangle, you can see side AC is intersected by side BD. One side of that is a right angle, therefore the other side must also be. So, if you find it more useful to go ahead and tack that on, I'm going to, just really faintly, then feel free. But I know that triangle ABD is also right. And then when I take a peek, I was given an angle. I was given a side length. Hey, I can use my SOHCAHTOA to find properties. So there becomes my strategy. What I hope that we get really focused in on is almost like this movement where we progress through triangles. Remember what we started off with. I could not use triangle BDC because I didn't have a side length. So my goal becomes, can I get a side length on that triangle? And what I'm going to be focused in on is a side that's shared between those triangles. That's my strategy. So what I want to do is I want to find the side length of BD first. Then I can use that to find X. Okay, there's my strategy. Let's go ahead and use it. You'll notice I'm going to use all my proper labels, which means I'm going to put my little headings in for what triangle I'm working in. So, to start off, I'm going to work in triangle ABD. That's my right triangle on the left side. And what I want to find is side A. That's my shared side, which would allow me to solve for x. So from my angle perspective out, side A is opposite. I was given my hypotenuse, opposite and hypotenuse. There is my sine ratio. So the sine of 25 is equal to A over 23. And this now should be automatic for us. Like I'm almost hoping we can kind of shut our brain off and just keep trucking through and solving that equation. I get down, there's no rounding rule stated, so I round to 2 decimal places, and I'm good. So I found out that that side length of A was 9.72. If it helps you as you're working through, then label your shared sides. Now that I know that that side length is 9.72, that was a piece of information that could have helped me before. Okay, I am going to jump over now into triangle ACD. I'm going to work with the right triangle on the right side. Because from my angle out, side X is my hypotenuse. The 9.72 side, that is my opposite. I can use my sine ratio again. You'll notice I didn't really have the option to not use rounded information. So this is one of those little asterisks that comes back into play that says use exact unless you can't. I could now say that the sine of 50 degrees is 9.72 over hypotenuse. There's my opposite over hypotenuse. And I'm going to shrink that down to fit some stuff in. We should be quite comfortable to multiply out our x and divide out our sine 50 at the same time. And now that becomes a little bit of button pushing. Same thing, we should be good on keying sequence. I am rounding that off to 12.69, and I'm dealing with centimeters. And there we go. Okay, there is our second official problem because we've dealt with one in a previous lesson. But there is our first working with multiple triangles problem for today. Hopefully it went pretty smoothly. And you can see that all we're doing is just combining or using all the skills that we've had from previous days. Okay, that's what I want to do today. I want to play around with a couple more, make sure that we're solid. Okay, let's try one. Okay, you take a look what's on the screen. Now within this problem, I have asked you to find the measure of angle R. I think you have enough to give this one a shot. So I want you to go ahead. I want you to pause the video now, see what you can come up with. Okay, pause it now. Okay, we are back. Now, I just want to briefly touch upon something that you may have been tempted to do. And this is with our eyes. You may have been tempted to go, hey, this line up on top looks horizontal, and this line is horizontal. Which means, hey, wait, this looks parallel, I should say, to that. Hey, this looks like a parallelogram. So, angle R, 32 degrees. Nice. And I hope we didn't. You cannot trust your eyes on your diagram when it comes to parallel or equal lengths. They have to be marked. And since they're not marked on that diagram, you can't assume. Okay, to knock that error out of the way, then I hope for us to come up with angle R, well, you either needed to know the other angle, angle Q, because then you could have found angle R, or because you have this one side length here, if you found out either of the other side lengths, you would have enough to use your SOHCAHTOA to get there. Well, that second question mark that I put on, that happens to be a shared side in that diagram. And if I hop over onto my other triangle, then you can see, hey, you have enough information over there to be able to come up with that shared side. Okay, there's my strategy. Here we go. So I'm going to start off working in triangle PQS. And within that triangle, I'm looking angle out. My shared side would be my opposite side. That's side P. I was given hey, there's my sine ratio again. Nice. So my sine of 32 is going to equal my opposite side over my hypotenuse. Multiply it out. And calculate it and round off. We get a value of 7.95 following our rounding rules. Okay, you now know P. I'm going to get rid of P. We can see that on our label. I'm going to replace it just because you may have. But since this is only our second one going through, maybe you want to write that on. Now when I jump over to my other triangle, triangle SQR, for me to find angle R, I now know my opposite and my adjacent. That's my tan. So my tan of angle R is going to be 7.95 over 9. Okay, I think we should be okay to jump straight to a value for R. Just remember, you can write in that line that shows the inverse of 7.95 over 9 if you wish, not needed though. If we go backwards and we take the inverse, just remember, keying sequence, make sure that we've got brackets in there. We're going to follow our rounding rules, which means to the nearest degree, and that is 41 degrees. 41.45523, blah, 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 blah. There we go. Okay, I'm hoping that one went pretty well. I'm hoping strategy-wise you could map through it, and then if we did not match up in the end, it was for some silly mechanical mistake. Okay, I want to work through one more problem for today. Okay, you'll notice in problem 3, I have been very explicit. I would like you to find the length of X. And to be very clear on my diagram, side X runs from that line to that line. That's what I'd like you to find. Okay, you'll also notice my diagram has no labels. So, when you go through to attempt this one on your own, make sure you label your diagram so your reader understands your solution. Okay, I want you to try this one on your own. We'll see if we can come back with a proper value for X. Okay, pause it now. Okay, we're back. So if I was to go through and just put some labels on, I'll just label it in orange. Maybe I call this A, this B, this could be C. That gives me a big triangle ABC. But then I've also got this other small little triangle in there. So maybe I call this D and this E. I don't know. I just hit every vertex with a label. Okay. If I could map out my strategy, we've tackled a problem like this in our past. Maybe we can see that if you could come up with the entire length across the bottom and then come up with part of the way across the bottom, then X would have to be what was left over. Okay, what's driving me towards that? Well, it's because I take a look and I notice I have a right triangle in triangle ABC. But I also have a right triangle in triangle EDC. Because those are two right triangles, I can use my SOHCAHTOA on them. Nice. Real nice. Okay. I'm going to work my way through. Take my time. use my labels, and make sure I'm good. Okay, so to start off, maybe I'm going to work through, I'm going to do this in purple. I'm going to start off working in triangle ABC. And what I'm going to do is I'm going to find all the way down the bottom, all the way across, the length of AC. Well, the length of AC in that diagram is B. So I am going to find B. Okay? Well, when I look in that triangle, I was given an angle. There's my 38. And I was given a side length, 15. From the 38, side 15 is opposite. Side B is adjacent. Hey, there's my tan. So I could say that the tan of 38 degrees has to be 15 over B. Okay, I should be pretty quick to solve that. Multiply out my B and divide out my tan 38. I get my B equals, and I can get my approximate as I'm pushing buttons. That is going to get me to a 19.2 when I round. Okay, that gave me my B value. I'm going to just get rid of that, and I'm going to write it on my diagram if that helps you out. All the way across. Now what I'm going to do is I'm going to jump in blue. You'll notice that that angle of 38 also exists inside my other triangle. So when I go to jump to work through triangle EDC, I notice angle 38, and I've got 10 again. The side I am looking to solve for is this side D. Okay, opposite and adjacent relative to 38, I get my tan ratio again. So the tan of 38 is equal to 10 over D. I'm going to slide that all up. Everything that we mentioned before, you should be good to get to that exact value for D. And now when I push some buttons, that is going to get me approximately 12.8. rounded to 2 decimal places. Okay, now that I've got those, my reasoning is going to kick in with my x. I can now come up here because I know, there's my therefore, that my x value has to be all the way across the bottom minus part way. And if I take my 19.2 and I minus my 12.8, then I'm going to finish with 6.4, and that is 6.4 centimeters, and I am good. Nice. Okay, there we go. I don't think we need to go through much else. Like, we just tackled 3 problems where we were able to work through multiple triangles to find something that was missing. Your job now. Jump through and get some more practice with this stuff. Try to make that idea of finding your strategy by working through multiple triangles as automatic as possible. Okay, good luck with your practice.